Okay, students. So let us continue with the application of integrations. Okay, I'm going to start the important problems on application of integration. In this particular topic, you must know what is definite integration. If you know what is definite integration, then it is going to be very easy to understand the application of integrals. Clear? So that's why first you understand what is a definite integral. Then let us go on watching uh, about or let's go on moving with the problems on application of integration. So you just see the integration from a to b f of x dx is going to be equal to capital F of x from a to b, where the derivative of capital F of x is small f of x. So from this you get capital F of b minus capital F of small a. From that you can just see you are going to solve this definite integral as, suppose this is f of x. Now I am going to divide it into some intervals. I will divide these things with some intervals, and I will calculate the areas of this particular strips. Here this is delta x, here this is delta y, this is delta x1, delta x2, this is delta y, so on. This is delta xn and this is delta yn. If I calculate the areas of this particular strips, you can get delta x into delta y plus delta x2 plus delta y2 plus delta x3 into delta y3, so on to plus delta xn into delta yn is going to be the area. Okay, so the calculation of this area of these strips is going to be area under this curve. Clear? From A to B, from A to B. So this is the simple understanding of your definite integrals. And here we can also see that these definite integrals are going to be very useful in calculating the area under the curve, So for that we shall go on taking one example and we shall solve it. So after simplifying that particular example, you can just understand what is area under the curve and what are the applications of area under the curve. For example, first let us take find the area enclosed enclosed by the circle by the circle x square plus y square equal to a square. Okay, so now you can just see from this is the equation of circle. So for that, if I take this is the circle, this is going to be the radius. This is going to be the radius of the circle from 0 to a, because this is x minus a whole square plus y minus b whole square equal to r square, where r is equal to a. That's why this is the length of the radius. You can just calculate the area. enclosed by circle means if I multiply this area with 4, so that you will get all the complete area. For that you can just see required area is equal to integration from 0 to a curve y with respect to dx. Here curve y means this has to be converted to y. That will be 0 to a square root of a square minus x square with respect to dx. So here formula of this particular integration from square root of a square minus x square you must know. Okay, so that is uh, required area for complete circle is 4 times. So 4 times of area means this will be x by 2 root of a square minus x square plus a square by 2 sin inverse of x by a from 0 to a. This will equal to 4 times of, if I put a here this will be 0 plus a square by 2 sin inverse of 1 will be pi by 2 minus, again if I put 0 here this will be 0, sin 0 will be 0, and if I simplify this you are going to have 4 times of a square pi divided by 4, 4 will get cancelled, a square pi square units is going to be the required area of the circle. Required area of the circle. Sometimes they ask only from first quadrant, then you can just write only integration from 0 to a. If they ask from first and second quadrant, you can just multiply it with 2. If they ask complete area enclosed between this circle, you can just say 4 into 0 to a. From that you can just understand what is area enclosed by the circle. What is area enclosed by the circle? If you have any doubts, just put the question so that I can reply for you. So if someone gets any problem or any doubts, you can just ask. I can reply for it. So now just let us go for second one. Find the area enclosed by x square by a square plus y square by b square equal to 1. That is ellipse. That is going to be ellipse. So from ellipse you just know that this x square by a square plus y square by b square equal to 1. Okay. So now area enclosed by the ellipse is going to be 4 times from 0 to this particular term, that is x intercept a, y intercept is b. Here x intercept is lesser than y intercept. That's why you are going to have like this 0 to a, and now y with respect to dx. So x square by a square plus y square by b square equal to 1. Now y square by b square equal to 1 minus x square by b square. So x square by a square. y is going to be, y square is going to be equal to b square into 1 minus x square by a square. Just you can check that b square by a square will be a square minus x square. If I take y, it will be b by a root of a square minus x square. B by a root of a square minus x square. So from that you can just simplify these particular terms and you can understand. Now this is going to be equal to 4b by a integration of square root of a square minus x square from 0 to a with respect to dx. Is 4 times of b by a. As you all know, the formula that we have seen here, a square minus x square is x by 2, root of a square minus x square is x by 2 root of a square minus square plus a square by 2 sine inverse of x by a. Okay. So from this you can just go on simplifying. You'll get your required answer from 0 to a. If I put a, this term will be 0. You are going to get just 4b by a. If I put a, this will be 0. This will be a square by 2. Sine inverse of a by a is 1 by 2. A square pi by 2. Another term is going to be 0. No problem. And now this is required area, that is 4b by a. You can just see this is a square pi by 2. If you put a, this will be 0. And if you put a here, this is a square by 2 minus, if you put 0, this will be 0. Sine inverse of 0 is 0. A square pi by 2 you are going to get. So from that, a square by 2, this is as it is, a square by 2. And now here you will get sine inverse of 1 is pi by 2, so that it will be a square pi by 4. 4 will get cancelled, a will get cancelled, a b pi. You are going to get ab pi. From that ab pi you can just understand what you can solve for the given ellipse. Clear? So like this you can go on solving that particular problem. You can get the solution. Okay. Coming to the previous problem. Here suppose what is area of circle? A square pi. Now area of circle is going to be equal to a square pi. Suppose if you have x square plus y square equal to 4, directly you can write area of circle is equal to a value is 2 square pi, that is 4 pi, because x square plus y square equal to a square. This is the formula. So here you are going to get 2. 4 pi will be the answer. Suppose if you have x square plus y square equal to 2, you can just write it as area of circle is 2 pi. Clear? So these things are going to be the shortcuts. This is the shortcut, very very important shortcuts. Okay, because if you go through your method, you have to simplify all these terms. If you go through all these terms, it will take very much big time. So don't waste time in your CET exams. Directly you remember it. And from that you can just directly write, that is area of circle is 2 pi. So next, area of ellipse. Area of ellipse, what you got? AB pi. Area of ellipse you got AB pi. Suppose if they say integration of x square by 16 plus y square by 9 equal to 1. Here a value is 4, b value is 3. AB pi will be equal to 12 pi. 12 pi square units. 12 pi square units is going to be the answer. And this is also going to be the shortcut for your CET results. Shortcut for your CET problems. can just go on solving these particular problems, and for that you can just do these things. So Sri Vidya Venkatesh is asking that, sir, is maths NCRT enough for KCET? You have to go through NCRT textbooks, NCRT fingertips, and some one more any type of book that is like MCQ. Then only you can do your KCET preparation. Only by doing NCRT you are not going to get the problems, or you are not going to be having the complete information. You are not going to have the complete information. That's why you just go through two or three books. With NCRT you take fingertips, and with that you take one any last 10-year question paper solved book, and you can, with that you can just go on solving. So in this particular session, the very important thing is area of circle. Very important is area of ellipse. Area of ellipse, this is a square pi, and this is ab pi, that you can see. Okay, these two are going to be the shortcuts, that is ab pi, and one more is a square pi, and you can use these two shortcuts very easily, and you can solve. For example, in the exam they give, find the area of circle x square plus y square equal to 3. Option A will be 6 square units. Option B will be 6 by 6 by 31 square units, and option C will be 3 pi square units, and option D will be none of this. So here you just remember this formula, that is a square pi, so that this is going to be equal to 3 pi, because x square plus y square equal to a square is your answer. So here a square is 3, that's why it's a square pi, that is 3 pi is going to be the correct answer. So like that you can just go through these two shortcuts. So from that, these two shortcuts you can simplify these problems. So ab pi and a square pi and ab pi are very important. Okay, so I think that these things are enough for this particular session, and in the next session we shall solve some more problems. We can solve some more problems, and let us see in the next session, and let us see some more problems to be solved in the next session. Okay, and you go through these two problems, that is a square pi and ab pi, circle, and this is ellipse. Clear? And in the next session I am going to solve area under the area bounded between the triangles, area bounded between the lines, area bounded between the curves. We shall see in the next session, like solving the problems bounded between two curves like this, or two circles, and we can also solve area bounded by the triangle. These all are very important problems. So this circle and ellipse is already over. So in the next session we shall go for our triangle, curves, and circles, area bounded by the circles. Okay, so we shall meet in the next session, and let us see.